All right, so a little review on solutions for your test tomorrow. Let me know if you have any questions tomorrow morning. I will be in there ready to help you guys out. So, um, learning target number 1. So it says describe the component parts of a solution. So with a solution, you have what is called your solute and your solvent. All right, your solute, it is what is being dissolved. Whereas the solvent is the dissolving medium. All right, so what is doing the dissolving? Alrighty. Um, so if you think about like a cup of tea, all right, the tea would be the solute. All right, water would be the solvent. All right. If you think of sugar water, okay, sugar would be the solute, okay, and the water would be the solvent. Those are the components to all solutions. Okay, you have to have something that's being dissolved in something else. All right, the solute is also considered the smaller part. All right, the solvent is the larger part. Okay, because once you aren't in that equilibrium anymore, that's when you get a saturated solution. Okay, all right, so learning target 1, let me know if you have any questions on it. All right, number 2 is I can compare the amount of solute present in saturated, unsaturated, and supersaturated solutions. All right, so let's look at that first part of this. All right, so an unsaturated solution, you guys, we see my awesome handwriting. Unsaturated. All right, this means that more of that solute can be dissolved. Okay, so more solute can still be dissolved. You will not see any crystals. All right, so no crystals at all. If you add more crystals, they'll still be dissolved. Okay, so you can keep adding if it's unsaturated. If you add more in, all right, they're going to keep dissolving. Alrighty. A saturated solution, okay, it is now we reached that equilibrium. All right, so there are more solute particles, right, than what can be dissolved. Okay, so more solute than can be dissolved. All right, and so you're going to see crystals actually being formed. Okay, so they'll be left in your test tube, they'll be left in your beaker, in whatever solution, you will actually see crystals that are left in them. All right, if you add anything more, add more solute, all right, it will not be dissolved. All right, so that is how you know if it is a saturated solution versus an unsaturated. All right, supersaturated is really unique. All right, what happens is this is where you have more solute dissolved, okay, than a saturated solution. All right, but it is all dissolved, Okay, all of it is dissolved, right? You cannot see any crystals, all right? But what's unique is if you add one more crystal to it, all of a sudden it's going to appear. So like in our lab, we added one more, all of a sudden it appeared and it happened. Okay, it just happened out of nowhere, okay, with the sodium acetate. All right, so that's what the difference is between them. Whether you can identify whether they are a solution on a saturated, unsaturated, or supersaturated by analyzing a graph. All right, so if we look at our graph, all right, why is this not moving? So if we look at the graph, over here, okay, remember if it's on the line at all, okay, or above, it is saturated. All right, if we were looking at KNO3. If we're looking at KCl, it's this line, all right, and ACl is that one, okay? Below it is unsaturated, okay? Supersaturated, we're not going to really analyze them at all on this graph, okay? Remember how to use this. If you're given a temperature, it's asking you how many grams are going to be dissolved. So if we are given 70 degrees, all right, and we want to know how much potassium nitrate, okay, can we dissolve? What would be that right when it hits that equilibrium? Oh, we go over. We could say we could put in 130 grams. All right, with mixing it with 100 grams of water if we were at 70 degrees. Okay, if it is, then you can do the opposite. If I have 70 grams of the potassium nitrate, what temperature would I have to heat it up to? Well, you go down and over, so about 45. All right, so that's how you're going to use your graph. The last one, number 6, what percent? What you do with that, that would be percent by mass. All right, so if we are looking at 80 degrees, all right, what would be the percent by mass of the potassium chloride? So you go to 80, all right, you figure out, okay, well, I'm going to be able to dissolve 50 grams. That's 50 grams of my solute, all right? But then you need to figure out, okay, what is my total grams of my whole solution? So I take my 50 grams, it's in 100 grams of water, so that's where I get my 150 grams, all right, of solution. So then my whole percent would be about 33%, okay, because I divide them. All right, that's what you do. You want to make sure that this bottom is the whole solution. All right, so I'm going to pause it here. Next one, we'll talk about a few more of the learning targets. Alrighty.